So this is the one section I kind of felt like you guys did okay with, which was inverses. This was the one when I had passed back your packets the other day. I gave like the bonus if you got the harder inverse where you had to cross multiply, distribute, take out a GCF, and then solve. So a couple of you definitely got it. So that was something I was proud of because that told me, okay, their algebra skills are good in terms of inverses. Inverses in calculus are super important because they are canceling functions. So there are times like with the half-life problems, you had to ln the e to get the e to go away. So we use inverses to get rid of functions. Or with the sine and the arc sine, you use that to get the angle. So if you didn't catch that, when we were talking about sine and arc sine the other day, just like ln of e of x is equal to x, the sine inverse of the sine of theta would be equal to beta. Because again, these are canceling functions. Or the square root of x squared. But this one is kind of tricky because this is even, that's odd, so it's actually the absolute value. But the square root and the x squared are canceling functions, leaving you with x. So again, we have inverses all over mathematics, just sometimes we don't call them what they are. So calculus is really like the discovery of math. We kind of figure out why does the math we've been doing for all of these years actually work. That's what we do in Calc. We figure out why it works. So we actually show why the quadratic formula is what it is, how in terms of the quadratic formula, and why things happen in the quadratic formula, the mins and the maxes, and where they occur. So I like Calc for that reason, because I feel like Calc teaches you the whys that you never got to really ask before. So the warm-up, we can go through quickly. You can probably do it on your own now, because we've been doing math and composition, and you're getting so much better every day.
So the first two have the number, so are we just like, for 3 and 4, we're just leaving whatever, so like g of x is just staying like x squared plus 1, and then we're plugging it into the...
Exactly. So like if you're given a number, so f of g of 7 means that you're going to get a number answer. If you have f of g of x, you're going to get a function answer.
What?
No, in the video, it's just we're gonna be laughing, and then you're not gonna hear what we're laughing. We're like,
Oh my god.
Who made that?
Mr. Block's class.
Silly freshman. go over the first couple. So we have f of g of 1 is equal to 1. G of f of negative 7 is equal to 5. And then f of g of x is equal to x to the 2/3, which is the same as the cube root of x squared. And then g of f of x is equal to x minus 1 to the 2/3 plus 1. Yeah.
So when there's like a cube root, should we like make it to that to the exponent? Like should we do that when we see that there's like a root like that?
So if it helps you, like so when I did that one, I would have, do you want me to do 3 or 4?
4.
Minus 7 minus 1. Minus 8. In cube roots, you can have negatives.
I know that.
So you get negative 2.
Maybe.
Then you have to take negative 2 and plug it into the g of x function. So negative 2 squared plus 1.
So like that is fine.
Okay, so that's what I
Yeah,
had.
because I wrote it, I said that for the third one. Like I said it, like I read that and then I said this.
Okay.
So, but yeah, it doesn't
So
matter.
like they were.
I forgot to select first
Okay.
before plugging.
It's like that one I did yesterday that like you could write it 5 ways.
Okay. Alright.
Yeah.
Okay, because I got the one where you put like the 2/3, like x to the 2/3 in number 3.
I got
Yeah.
I didn't
that,
think of doing it.
but then I didn't think about
Yeah,
putting
putting it
it
to the 2/3.
to the 2/3.
And again,
I
they're
didn't-
equivalent, so it doesn't matter.
I had the
Alright.
same thing for 3. I just left it in them.
Intersection.
Now these you would do on your calculator because it says round to decimals. So the minute you see decimal, you think your calculator. That is your indicator. So let's try one of the more like complicated ones. Like I'm assuming these ones are so easy you could literally do them by hand.
Yeah.
So go down to like 9a, go to your y equals on your graphing calculator. And then what I'll do is kind of walk you through almost how to do this. So you would clear y1, and in y1, you're going to put 2 to the x. In y2, you're going to put the y equals 3. So that's going to give you on your graph both of those lines. So anytime you don't know where your graph is set to be, Zoom 6 is a pretty safe graph function. Now, if you know your data is not going to match that, then you go to your window and adjust. So now you should have like a blue curve and a red curve, and they should hit each other per somewhere like whatever that is, 1.58. So to get that point of intersection, you go to second trace, and now it's option 5. And honestly, what's so nice about the trace feature for intersect, you could not move your cursor at all. Like mine was way over here, and it will still jump because the graphs only intersect once. If they intersect multiple times, then you have to move it. But like if they only intersect once, you can leave your cursor wherever it is.
Yeah.
It'll find it.
I was thinking
Mine
left
on
down, right down, I was like,
for my calculator. It only shows the 1.
Okay. I'll follow that.
So your
Hit
equal
second.
sign wasn't lit up.
Yeah.
Second.
trace,
I'm not sure why it wasn't lit up.
5, hit enter.
I should probably just tell you, after we do this, I'm going to hit the second plus sign, and we're going to change your
It's just
calculator
a-
back to all the defaults,
Yeah.
so that whatever you changed in like stat or trig last year, go with.
I should do that.
Yeah.
My question, my
Like
calculator's
everything's changed and I
questioning
don't
my
know.
intelligence. I don't like
Yeah, I
it.
don't know what's
What?
up with his.
My calculator's questioning my intelligence.
Okay.
It's asking, so many more questions than it needs to.
Because like you select the equals on it, but then it says both of them are selected. You press graph, and then it still doesn't show.
Yeah, you're like even those are like you have to put a sign.
Okay,
Second.
so what did you just do? You touch buttons and I don't know what buttons you touch.
So, I'm just gonna be clear. So, you have everything graphed, you hit the graph. Second, trace, you'll go down to 5 for intersect. I just moved it so it wasn't directly on it.
And then it
to
went
this
to it.
side.
Oh, I see.
His was saying like guess where
But
intersection
my
is.
calculator
Yeah,
just
they are
guessed.
It's 3 buttons. It's the first curve, the second curve, and the third curve.
X.
Or the guess curve. There's always 3. It's 3 enters. I literally just go, yeah, you have to hit enter 3 times.
That makes so much sense because I didn't enter once.
Well, yeah, that's hurtful. All right, a one-to-one function, an inverse, finding inverses, and actually we're going to talk a little bit about logs, property logs, and applications today. A function is a rule that assigns a single value in its range to each domain point. So basic definition of a function, for every x there is only one y. A function is the equation that we look at. Functions assign the same output to more than one input. That's allowed. So, for example, x squared assigns the same output to this different inputs. So, it means that that function is not one-to-one, but it is still a function. So, even functions are usually just not one-to-one. So we have the vertical line test and the horizontal line test. The vertical line test tells me if it's a function. The horizontal line test tells me if that function is one-to-one. So one-to-one says not only is for every x there only one y, but for every y there is only one x. So here are examples of functions that pass versus don't pass the horizontal line test. So horizontal line test states that the graph of a one-to-one function can only hit any horizontal line at most once. If it intersects a line more than once and assumes the same y value, it is not one-to-one. So the general definition of an inverse is that it must be a function and that that function must be one-to-one for an inverse to exist. Now you can find inverses of non-one-to-one functions, and what we have to do is restrict their domains. So for example, sine and cosine obviously have inverses. They have arcsine and arccosine. But if you remember on that first week of school, I had taught you that arcsine and arccosine only lived in certain quadrants. That is why we've restricted their domain to match their inverse. Because an inverse takes the range of the original and it becomes its domain, and the domain of the original becomes the range. All of the points flip each other. Using the horizontal line test, determine whether the function's below or one-to-one. You might know without even graphing. So you could kind of picture the graph in your head. So absolute value is a v. A square root is basically half a parabola turned on its side, because the square root is the inverse of x squared with a restricted domain. So no pass, yes pass. Inverses say that each output of a one-to-one function comes from just one input. A one-to-one function can be reversed and send the outputs back to the inputs from which they came. So again, if AB exists on the original, then BA exists on the inverse. The function defined by reversing a one-to-one function is known as its inverse. Composing a function with its inverse, hence function composition is our review at the beginning, sends each output back to the original input from which it came, thus giving the identity. So what that means is f of g of x equals g of f of x, and they always equal x. So if f and g are inverses, then g of f of x will equal f of g of x, and that will equal x. X is known as the identity function. It is the basic parent function in math. Inverses are read as f to the negative 1 of x, but we don't say f to the negative 1, we call it f inverse. Everybody assumes that f to the negative 1 means it drops it down, like we talked about exponents yesterday. That is not the case. F inverse is not 1 over f of x. The inverse is not 1 over f of x. So by using function composition, we're going to determine if two functions are inverses of each other or if they are not. So I'm going to plug g into f. And f into g. Stop writing for a second. So when you do this one, I get x for one of my compositions, but I get the absolute value of x for the other. Is the absolute value of x equal to x? No. So these are not inverses of each other. That should make sense because x squared does not have what? Like x squared does not have what property, which is why these fail as inverses of each other.
Because it's always positive.
Kind of. So think about if x squared is always positive, its graph is going to look like this. So what property of inverses does it fail?
Horizontal line test.
Fails a horizontal line test. It's not 1-to-1. If it's not 1-to-1, it cannot have an inverse by definition. So x squared isn't 1-to-1, therefore no true inverse of x squared exists. Now, what you could do is restrict x squared's domain and create an inverse. So if this problem had said g of x equals x squared and x is only greater than or equal to 0, now when you take the square root of something squared, since x squared could only ever be positive, the absolute value would be null and void. Thus, they would be inverses. But that's why I said a restricted domain creates an inverse at times. To create an inverse function, there are 4 steps. The first step is to rewrite it in terms of y and x. The next step is to switch x and y. And again, you can shorten that. A lot of you, I think, knew how to find inverses. So, and then you solve for your y and then switch them back. So if you're given y equals 4x minus 12, we know that a line is going to pass the horizontal line test. So you start at negative 12, and then you go up 4 and over 1. So that means that this graph would have the point 1, negative 8. Do it in blue. And then you go up 4 more and over 1. Why did all my other points just disappear? Dead. Like, doesn't want to draw dots. Oh, fucking. Okay, so then find its inverse. So to find its inverse, we would take x and y and flip them. So you have x equals 4y minus 12. Solve for y. And you get 1/4 x plus 3. So then you would plot your points. So you have 3, 0. Well, 0, 3 technically, sorry. And then you go down 1 or up 1 and over 4. See, I drew that one. And now it's gone. Whatever. And then it doesn't draw where I want to draw. It's just kind of a pain. Oh, I know why, because I'm in PowerPoint, not Promethean. This is why I put everything back in Promethean. PowerPoint like goes crazy. All right, so what I want you to notice is that these graphs, mine are not, but yours are hopefully symmetric about the line y equals x. So the line y equals x is the line of reflection for inverses, because again, this graph contains the point 0, 3 on its original. On its inverse, I'm in the wrong color. And it contains 3, 0 on the original, because the points are reflected across y equals x, hence flipped. I'm confirming that those are right. 1 to 6 are definitely good. I already looked at them and I was like, yeah, I like these. 8 to 24. That 1, they're even, so I'm going to change that. And I don't really think we need to worry so much about the beginnings. So we're going to do this. Here's my keyboard. I like 1 to 6. And then we can do 13 to 23. But what I'm going to have you do is every other odd. So I'll do like 13, 17, skip 19, 21. So you only have to do like 3 of them because they're a little lengthy because they're the function compositions. So again, it would be 13, 17, 21. Hold on. No, there's still a few more.
7, sure.
Yes.
21.
No.
Why did it change that to QU? I did. You all watched that, right? Like it said 17.
The space.
It's just trying to correct your error.
It does the same thing whenever I'm like typing numbers on my phone.
Whatever,
And I
yeah.
hit like the space bar after, it always
13, 17, 21.
Yeah, because it's trying to autocorrect what you're writing into it. I hate it when it does that. Try saying that where it gives you an entire different word.
And what's bad though is like I know where the numbers are on my keyboard, so it's like I'm typing the right keys.
I know I'm not.
43 to 45. Do we want to try another Half-Life problem? Because there's a nice one in there.
Ideally not, but it's not up to us really.
If we do, it's like half a bonus point.
Maybe we get like some at least.
Well, it's one problem. Which is
Can it like
See,
not
this
happen?
got upset with me a little bit yesterday because whenever he asked us to put the number we thought we got on the paper, I put like something 0.8.
43.
0.8. I think 2.75.
It sounded like a really nice number.
Hey!
0.8 does sound like
Yeah,
a pretty
it's
nice
like
number. I'm not gonna lie.
37.8.
And 56.
There you go.
52 and
That's a
56.
lot.
Oh, it is not.
Actually,
The first 6 are yes and no. Like-
13 problems already. 13.
Yeah. If you think that's a lot, then you're